All right, so let's look at a third example of how to solve a rational inequality. So I have the rational inequality here, x over 3x plus 4 minus 2 over x minus 1 is less than or equal to 0. So what we need to do for this right off the bat is we need to write this as a single rational function. So we want to subtract these fractions. So to do that, we're going to multiply my bottoms together. So I have my 3x plus 4 and x minus 1. And then I want to multiply up in this direction and this direction. So we're going to do x times x minus 1. The reason why is this fraction is missing the x minus 1. And then we're going to do minus 2 times 3x plus 4. And the reason is because this fraction is missing the 3x plus 4. And that's going to be less than or equal to 0. We are then going to go ahead and distribute and clean up my top. And I got x squared minus x minus 6x minus 8. All over, still my denominator, 3x plus 4, x minus 1 has to be less than or equal to 0. All right, from here, clean up the top, still a little more combined like terms. I've got x squared minus 7x minus 8 over 3x plus 4, x minus 1 less than or equal to 0. The top factors to x minus 8, x plus 1, all over 3x plus 4 and x minus 1. This has to be less than or equal to 0. Okay, so now that we have it nice and simplified down, all we need to do is find my critical values and do the inequality test to see where the answers, the solution set's going to be. So what we're going to do is we're going to set my denominators equal to 0. So I have x minus 8 equals 0, and I have x plus 1 equals 0, and in this case my x can equal 8 and my x can equal negative 1. All right, now let's take my denominators and I'm going to set those not equal to 0 so I remember that they cannot be included. So we're going to do 3x plus 4 cannot equal 0 and x minus 1 cannot equal 0. All right, so from here we're going to simply solve. We're going to see that x cannot equal a negative 4/3 and x cannot equal 1. All right, so inequality test time. So we're going to put them in the correct order on the number line, or basically the x-axis. So I have a negative 4/3, I have a negative 1, I have a 1, and then I have 8. Now what I'm going to do, so I don't forget about this not equal sign, is that the negative 4/3, I'm going to go ahead and make this an open dot so I remember that it can't equal it. And then that 1, I'm going to make this also an open dot so it cannot equal it. That's a nice way for me to remember, a little way for me to remember that it cannot equal it, so I have to go back and reference and mess up my answer. All right, from here, I've got my critical values of negative 4/3, negative 1, 1, and 8. I want to pick numbers to test. I'm going to test, let's say, negative 10. I'm going to come back to this one. The number between negative 1 and 1 is 0. Between 1 and 8, let's pick 5. That's easy enough to do math with. A number bigger than 8, let's do 10. That's easy to do math with. Here, sometimes when it's not so obvious, I default back to geometry, my old midpoint formula. If we remember from the midpoint formula in geometry, we would just take the average of my x's and my average of my y's, and that would be midway between those 2 points. Well, in this case, this is the x-axis, a number line. It's one-dimensional, it's the x-axis. So I can do the midpoint of this by simply just taking the average of negative 4/3 and negative 1. So I can do negative 4/3 plus a negative 3/3, and I'm going to divide it by 2 because I'm adding 2 numbers. I'm taking the average of those 2 numbers. This will end up being negative 7/6 when you do the arithmetic. So my test value here is negative 7/6. Sometimes you can't necessarily, it's not real easy to see what number is going to be in between certain numbers. So sometimes don't forget, you can use that geometry skill of your midpoint. All right, from here, we're just going to take our 10, we plug it in here, and we're going to look to see, is this a true or false statement? I'm going to tell you right now that this is false, so this does not work. When I put negative 7/6 in here, this is going to work. When I put 0 in here, this will not work. Putting 0 in here. When I put 5 in here, this will work. And when I put 10 in here, this will not work. So my solutions is between these intervals. So my actual solution set, so my x is actually going to equal, I cannot include my -4/3, but I'm going to go up to -1 and I can include it. I have a jump. So 1, I cannot include my 1 because that would make it 0 in my denominator. And I'm going to go up to 8. And I can include the 8. And that's my answer. Not terribly bad. I think the only reason why I really wanted to show you this problem is because of this part right here when it's not easy to see what numbers are in between. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.